In this video on latitude and longitude, we're going to review some important characteristics of latitude, longitude, meridians, parallels, and we'll also learn how to figure out latitude and longitude and how to find locations with latitude and longitude. So for this video, you need quite a few things with you. You need your textbook. I'll be referencing illustrations in your textbook. You'll need your Earth globe. You'll need a calculator. You'll need a ruler, a printed copy of the presentation that goes with this video, and a printed copy of the study guide that goes with Chapter 1. As you watch the video, please feel free to stop the video at any time, in particular when you need to work out problems on your own. And all figures that are referenced with numbers in this presentation are from Chapter 1 in your textbook. So first, let's talk about circle. As the Earth is a sphere, or approximately a sphere, we need to understand a few basic characteristics of circles. For example, we need to know how many degrees of angle there are in a full circle, how much of a circle does 180 degrees represent, and we should know what a right angle is, what a 90-degree angle is, and what a 45-degree angle is. So you have one circle on your slides. You should be able to mark on there a right angle, a 90-degree angle, and a 45-degree angle. And then I'll come back to the full circle afterwards. So a right angle, this is a right angle here that I have drawn in red. A right angle is also a 90-degree angle. So a quarter of a circle is 90 degrees of angle. So knowing that a quarter of a circle is 90 degrees of angle, you can easily figure out what a full circle is. It should be 360 degrees, and you should write this back on the slide, on the preceding slide. And then half a circle would be twice a right angle, so it would be 180 degrees. So on your slide that has a circle, you should mark a right angle, and you should mark it as 90 degrees. And then to figure out a 45-degree angle, you just have to kind of eyeball it and cut this angle in half. So here's an example of a 45-degree angle. And actually, by doing this, I've drawn two 45-degree angles, one below the red line and one above the red line. So sometimes the difficulty about latitude and longitude is that they are expressed as degrees of angle because the Earth is a sphere. So that's why we use degrees of angles and we don't use kilometers or miles and so on. And because 1 degree of angle of the Earth is really big, it's, I think it's about 90 miles, but we'll do this in another presentation. We need to be able to subdivide those degrees into smaller units. So the way degrees of angle work is that we divide degrees of angles into minutes of angles, and we divide minutes of angles into seconds of angles. And it works exactly the same as for hours of time. You all know how hours of time are divided into 60 minutes of time, and then minutes of time are divided into 60 seconds of time. So for degrees of angle, it's the same, but here we're talking about angles, not time. So in 1 degree of angle, there are 60 minutes of angle. They are equivalent, they're the same thing. And then each minute of angle is divided into 60 seconds of angle. So knowing that, on the next slide, we have examples of degrees of angle that are not written in appropriate form. For example, 75 seconds. Well, this is more than 60 seconds, and we know that 60 seconds is a minute. So to rewrite 75 seconds in a proper form, we would need to subtract 60 seconds from the 75 seconds, and that's 1 minute. And then what is left when we subtract 60 from 75 is 15. So the proper way to write 75 seconds of angle would be 1 minute, 15 seconds. For 85 minutes, we do the same thing. 85 minutes is more than 60 minutes, so it's more than 1 degree. So that means that we have 1 degree, that's 60 minutes, and if we subtract 60 minutes from 85 minutes, we have 25 minutes left. So 85 minutes rewrites as 1 degree, 25 minutes. For 145 seconds, now this gets a little more complicated because now this is more than, we don't just subtract 60 from 145 seconds because we're still left with a number that's greater than 60. So here we need to subtract 2 minutes, which is 120 seconds, and so we are left with 2 minutes and 25 seconds. One more thing we need to understand in order to understand latitude and longitude are map directions. And at this point, the only directions we need to know are north, south, east, and west. And we'll see that latitude is given as either north or south of the equator. And then longitude is given as either east or west of the prime meridian. So now let's talk about the geographic grid. So the geographic grid is what we use for finding locations at the surface of the Earth. And it's based on a basic grid system. So first let's talk about a grid system. A grid system is a system of reference in which 2 sets of lines intersect at right angle. So if you go to figure 9 in chapter 1, this is figure 9 in chapter 1. This is just a simple grid system. And they are labeled A through E at the top, 1 through 5 on the side, on the left. So we could describe the location of X as being 2B. And we could describe the location of Y as being 3D. So the geographic grid is somewhat similar to that. There are a few differences. First of all, we had to do a grid on a sphere, so not on a flat piece of paper. And that's why we're not using numbers and letters, but we will be using degrees of angle. And we'll see that here, if we compare this grid to the geographic grid, the numbers would correspond to latitude, whereas the letters would correspond to longitude for our actual geographic grid. So for the geographic grid, so the grid of the Earth, the points of reference are the axis of rotation of the Earth and the plane of the equator. So we use lines of latitude that we call parallels, and we use lines of longitude that we call meridians. So you have the geographic grid in figures 13 and 16 in chapter 1. So figure 13 shows the parallels of latitude, and then figure 16 shows the meridians of longitude. So you see on these particular illustrations, for the latitude, the parallels have been drawn at an interval of 10 degrees. And the longitude, same thing, they have been drawn at an interval of 10 degrees. What you have to keep in mind is that we could draw as many parallels or as many meridians as we want. On these particular illustrations, they have chosen to draw parallels and meridians at 10-degree intervals. So what I would like you to do is stop the presentation, look at your own globe, and then try to think of characteristics of parallels and characteristics of meridians. So think of characteristics in terms of describing parallels and describing meridians. What are the characteristics of these lines on your globe? Are they parallel? Do they converge? Are they all the same length? Do they change length? And so on. So again, you should stop the presentation now, and then I will list on the next slide some important characteristics of parallels and meridians. So the parallels are always parallel to one another. That's why they are called parallels. They get smaller in size as you go from the equator to the poles. And they're going to measure distance north and south of the equator. So they're going to give us our location, whether we are in the northern hemisphere or in the southern hemisphere. The meridians, they all go from pole to pole. So they actually converge at the poles, at both poles. They are all half of a circle, and they are all the same size. They are drawn north to south, but they are going to give us direction east and west of the prime meridian. And PM here stands for prime meridian. So the next thing I'd like you to do is look at your own globe and tell me how far apart are the parallels in degrees of angle and how far apart are the meridians in degrees of angle. So your globe is going to look different from this globe, and the spacing of the parallels and meridians may be different, so you'll have to determine that. So for this particular globe, I'm going to start with the equator in the middle, and then I'm going to find an area where I see the latitude numbers. So here, along the international dateline, usually I have the latitude numbers marked on each of the parallels. And then if I go to the prime meridian, which goes over England, here in Europe, so if I go to the prime meridian, usually I will find those numbers again. But on this particular globe, I don't. So you'll have to figure out on your globe where they are. So I'm coming back to the international dateline because that's where I see the latitude numbers. So I have here 15 degrees north, 30 degrees north, 45 degrees, 60 degrees, and then 75, and then eventually I get to 90 degrees north here at the North Pole. So the parallels are drawn every 15 degrees, and then I have some additional parallels as dashed lines, which are parallels that are important for the season, and that's the Tropic of Cancer at 23.5 north and the Arctic Circle at 66.5 north. And then this is replicated in the southern hemisphere. The parallels are also at 15-degree interval. So I have 15 south, 30 south, 45, 60, 75, all the way to the South Pole, which is 90 south. And I have the Tropic of Capricorn at 23.5 south, and then the Antarctic Circle at 66.5 south. So on this particular globe, the parallels are at 15-degree intervals. And then the meridians, the values for the meridians are written along the equator. So I will find 0 here, which cuts through Western Africa and goes through England, because that's where the prime meridian was defined, was this meridian that goes through England. And then I can go west of the prime meridian, or I can go east of the prime meridian, and I see that on this particular globe, the meridians are also spaced at 15-degree intervals. Okay, so first we're going to describe latitude, and we're going to refer to figure 12 in chapter 1. So on figure 12, you see a globe that has been kind of cut. It's like a quarter of it has been cut out, like a few slices taken out of an orange. So we can see the relationship between latitude and why there are degrees of angle and how it works in terms of being degrees of angles north and south of the equator. So on this exploded illustration, you see the red outline shows the plane of the equator. So you have to imagine a plane that cuts the Earth in half and it goes through the equator. So the red outline represents this plane. And then you see a location. Here they have Kuji in Japan. And it's on this particular parallel. It's on a particular parallel. And we're trying to figure out what is the location of Kuji in terms of latitude. So what was, in other words, we're trying to figure out on what parallel Kuji is. So what we do is, in our mind, or on this illustration, we draw a line from Kuji to the center of the Earth, and from the position on the equator directly below Kuji to the center of the Earth. And the angle between these two lines is the latitude of Kuji. So on figure 12 in your textbook, you see that Kuji is at 40 degrees north. It means that location makes a 40-degree angle to the center of the Earth with the equator. You see on this particular figure, you also have the location of Bowen, which is in the southern hemisphere, and in this case, it's at 20 degrees south. So this illustration just shows you how latitude, or why latitude is expressed as a degree of angle. Again, it's because the Earth is a sphere, and in a sphere, we have to describe locations with degrees of angles. We cannot use just simply distance in miles. So on the next slide, we're going to summarize the characteristics of latitudes. And for this, you can refer to figure 12, which is the one I just projected before, and to figure 13 in your textbook. So latitude can be described as the angular distance, meaning the distance as an angle, so not in miles, but as an angle, north or south of the equator. It varies from 0 to 90 degrees. If I go back to figure 12, you see it starts at 0 at the equator. Once I get to the North Pole, it's 90 degrees. That's a right angle. If I was to decide to go on the other side of the illustration, it doesn't matter if I go on the right side, like where Kuji was, or on the other side, I get to 90 degrees. That's the maximum angle that latitude could be at. Lines of latitude are called parallels because they are parallel to one another. And again, that's the north and south component of the grid system, so it gives you your location north or south of the equator. So now what I would like you to do is I would like you to go to your study guide, page 1, question 1. And question 1 has a list of the latitudes that you need to know. So you need to know their names as well as their location in terms of latitude. So in question 1 in your study guide, you need to fill out the values of latitude for these particular locations. And for that, you can refer to figure 14 in chapter 1 in your textbook. So once you're done, you can also fill out these values in the presentation itself. Once you're done filling out those blanks, I'm going to show you the answers. So this would be a good time to stop the video so you can fill out the answers to these different latitudes that you need to know. And the reason you need to know these latitudes is because they are very important for the seasons. So, and they have to do with the inclination of the Earth on its axis. But again, we'll talk about this when we get to the seasons. So again, this is figure 14. So figure 14 has all of the values that you need to answer question 1 in your study guide. And here are the answers that you need to fill out for question 1 in your study guide. And again, these, you are supposed to know these names as well as the latitudes of these specific parallels. Here I'll point out another thing. The North Pole and the South Pole are considered parallels, even though they are really only one point on the Earth. Okay, so these are parallels that are very small. They are just one point. Okay, longitude. To describe longitude, we're going to look at figure 18 in chapter 1. So in figure 18, you see the Earth with 2 imaginary planes cutting through the Earth. One is a plane that goes through the prime meridian, and then one is a plane that goes through the location that's under study. Notice that both planes intersect at the North and South Pole, because here we are looking at the meridians. We're trying to figure out the longitude, and the longitude helps us determine location east or west of the prime meridian. So how do we find the angle between, for example, Greenwich or the prime meridian and the location of Freetown? The angle is the angle that's made by these two imaginary planes that cut the Earth, going through both locations. So in this particular illustration, you see the angle is 13 degrees. So the longitude of Freetown would be described as 13 degrees west of the prime meridian. So characteristics of longitude, again in reference to figure 18, it's an angular distance. So again, it's a distance as an angle, and it's measured east or west of the prime meridian. It varies from 0 to 180 degrees this time, not just 90 degrees. So lines of longitude are called meridians. We're already familiar with this. And again, longitude describes a position on the Earth that is either east or west of the prime meridian. So that's the east-west component of the grid system. So let's look at figure 19. This figure also shows you how longitude goes 180 degrees. This is a top view of the Earth with the North Pole in the center. And you have the prime meridian would be this line. This is the longitude that is opposite the prime meridian. And when we look at the Earth from this point of view, we see the meridians as lines that converge towards the center, which is the North Pole. You can experiment with your own globe to see this. So again, we see that longitude goes 180 degrees east and 180 degrees west of the prime meridian. So on figure 20 in your textbook, you have latitude and longitude now together with particular numbers. And you see that on this particular representation of the Earth, now the interval is 10 degrees. So the parallels are 10 degrees apart, and the meridians are 10 degrees apart. Now, the purpose of this illustration is to show you that 1 degree of latitude is pretty much the same distance all over the globe, whereas 1 degree of longitude varies in distance from the equator to the North Pole. So remember that lines of latitude are parallels. So parallel lines are always at the same distance, wherever they are. So if I look at the edges of this paper, two parallel lines, they never meet. They are always at the same distance. And so 1 degree of latitude is going to be the same distance, whether you are at the equator or whether you are at the North Pole. So you see this on the right-hand side of figure 20. You see latitude shown at the equator is 111 kilometers. And then latitude shown at 60 degrees north is also 111 kilometers. Longitude is very different. Remember that the meridians converge at the poles. So along the equator, 1 degree of longitude is 111 kilometers. But once you get to 60 degrees north, notice that it's only 56 kilometers, about half. And then you get to the North Pole, and actually there is no longitude at the North Pole. You cannot describe longitude of the North Pole. The North Pole is at 90 degrees north. You actually describe the location of the North Pole just with latitude, 90 degrees north, because there is only one point that is at 90 degrees north. You cannot describe longitude. The longitude has no distance at the North Pole. Okay, so with all this in mind, I would like you to get your study guide back out and try to answer question 2. So for question 2, you have this map that's on the back side of the study guide. And you see values of latitude on the left and right-hand side and values on longitude at the top of bottom And then you see points A, B, C, D, E. So you're trying to describe the locations of points A, B, C, D, and E in terms of latitude and longitude by filling out this table. So I'm going to do A, so we can talk about the interval and exactly how these latitude and longitude are labeled. So you see for latitude, if I look at the right-hand side, you have 0 degrees, that's the equator. Then you have 20, it doesn't say north, but it's assumed north. And then you have 40 degrees north, 60, 80, and then it doesn't really show anything about that, but we assume the top of the map would be 19 north. So you see the interval is 20 degrees, except for the very top of the map, because we only have 90 degrees of latitude. Now, when we look at longitude, it's kind of weird the way they've labeled it because we don't know where the numbers fit exactly. So you have the middle meridian, that's the 0 degree meridian, that's the prime meridian. And then you have 20, and then you only have 60 east labeled, but you have another meridian in between. So really the meridians go from 0 to 20, 40, 60, etc. And then the right edge and left edge on the maps are both 180 degrees. So you have to be very careful when you read the longitude on this map because the way it's labeled is a little weird. So if we want to determine the location of point A, we see that point A in terms of latitude is on a 40 degree north parallel. So under latitude in the table, we would write 40 degrees north. And you always need to indicate whether it's north or south. Except when you add the equator, that's at 0 because there is only one of them. Okay? So for location of point A, you would write the latitude as 40 north. And then in terms of the longitude, you see that it's between the 20 degree west meridian and the 40 degree west meridian. It's about halfway, so I would put it at 30 degrees west. Okay. So with this in mind, this would be a good time for you to stop the video, and then I will, when you start the video again, I will post the answers to question 2. So here are the answers to the locations of A, B, C, D, and E for question 2 in your worksheets. And then if any of those, if you, your numbers disagree with my numbers, you need to go back and check where maybe something happened. These are the right answers. So next, I'm going to pose some multiple choice questions, and you should try to answer them, and then I'll pose the answers. Okay, so the first question, what is the error in the following coordinates? So the coordinates given are 5 degrees north and 165 degrees south. So among your answers, it says latitude can only be east or west. Well, that's wrong because latitude is north and south. Latitude can only be north or south. Now, this is a true answer, but that's not the answer to this particular question because latitude is given as north and south, so that's obviously not what is wrong with this set of coordinates. Longitude can only be east or west. Well, this is given as 165 degrees south longitude, so this is the right answer here. This is what's wrong with this set of coordinates. Okay. If we went along and read the other answers, longitude can only be north and south. That is incorrect. Latitude cannot be greater than 90 degrees. This is a correct statement, but it does not answer this question. Longitude cannot be greater than 180 degrees. That's a correct statement, but that does not answer this question. So this particular answer was C. On the next questions, I'm not going to go over every single answer. I'll just discuss the right answer and why it's the right answer. What is the error in the following coordinates, set of coordinates? So latitude is given as 95 north, and longitude is given as 165 east, while we know that latitude cannot exceed 90 degrees north. or south, but it cannot exceed 90 degrees. So the answer is E, latitude cannot be greater than 90 degrees. Next question, again, what is the error in the following coordinates? Latitude 5 north, longitude 185 east. Well, in this case, we have a longitude that's greater than 180 degrees, and that cannot happen. So the correct answer is longitude cannot be greater than 180 degrees. Next question, again, what is the error in the following coordinates? They are now given as latitude 5 west, longitude 165 east, where latitude, as we know, is only north and south of the equator, so the answer is B. Okay, next question. So you need to get your study guide out again, and I would like you to answer question 3 in the study guide. Now for this, you'll be looking at your atlas. You'll be looking for the political map of the world on page 3 in your atlas. Now in your atlas, you have to be careful. There are 3 sets of numbers. So you have first set of numbers, then you have city maps, that's the second set of numbers, and then you have world maps, that's a third set of numbers. So you're going to find the political map, page 3, in the third set of numbers. So for question 3, what you have to do is you're given latitude and longitude, and you have to find the most major city based on the map, page 3 in your atlas, that is located at those coordinates. So again, it would be a good time for you to pause the presentation so you can find out the answers to question 3 in the study guide. And then when you're ready to check your answers, you can forward the presentation again. So these are the answers to question 3 in the study guide. And so before I finish this presentation, I just want to add a few more things about some interesting characteristics of latitude and longitude. The first one is that the equator does not have a north or south. The equator, 0 degrees of latitude, there is only one equator. So when you have a location on the equator, when you give that latitude of that location, you don't add north or south. Same thing for the prime meridian. You don't need to say east or west, it's just 0 degrees longitude. So it's not east and it's not west. The meridian that is opposite the prime meridian, the 180-degree meridian, there is also only one of those. So it's also 180 degrees longitude without east or west. So there are some particular points on the Earth that are kind of interesting. The point that is at location 0 latitude and 0 longitude, notice there is no north or south latitude or east or west longitude. There is only one of those points. And then finally, the North Pole and the South Pole. As I mentioned earlier on, the North Pole is 90 degrees north. It doesn't have a longitude because all the longitudes meet at the North Pole, so it really doesn't have any longitude. If you are at the North Pole and you're trying to move, whatever direction you're moving to, you're moving south. So you cannot move east or west from the North Pole. Same thing at the South Pole. At the South Pole, you're at 90 degrees south. You cannot move east or west. There is no longitude. And well, if you imagine yourself at the South Pole and you're walking in any direction, you're walking north. Okay, so this concludes our presentation on latitude and longitude.